Hello everyone, welcome back to another BGCSE past paper review. Today we're reviewing a chemistry paper. This is a paper 3 from the year 2021. Again, as always, please remember to write your school number, your candidate number, your surname, and also your initials. Again, read through the instructions carefully and make sure you understand them. If you have any queries, please refer to your examiner. Again, they will provide you with a periodic table. You can use that throughout the examination to assist you wherever necessary. Also, they give you some important information here, for example, about STP and also about RTP. All right, so if you do need them, you can also use them as well. All right, we're going to try to go through this as fast as possible in time to catch the exam, hopefully. And so section A is to answer all questions. And they said an experiment was conducted in the laboratory for a fixed mass of carbon dioxide gas at a constant pressure. The data for the experiment is shown below. And so you see the volume, you see the temperature in Kelvin. And it said use a table to answer the following questions. And it said explain the relationship between volume and temperature for the fixed mass of carbon dioxide collected in the experiment. As you notice that as the temperature increases, you also know that the volume also increases. So they are proportional. And they stated that as the temperature increases, the volume also increased. All right, for part 2 is to name the gas law demonstrated in the data. And this is going for Charles' law because again, pressure is constant. And once pressure is constant, it is dealing with Charles' law. All right. And so based upon Charles' law, the relationship now is just about volume and temperature. And so therefore it's a write a formula for the gas law named. And so Charles' law will demonstrate that V1 over T1 equals to V2 over T2, or as simple put, V over T gives a constant. All right, for question part 4 of the same question, is a balloon at 293 Kelvin has a volume of 120 dm cube. If the temperature was increased to 323 Kelvin, what will be the new volume of the balloon? And so based upon this same formula, V1 over T1 equal to V2 over T2. Now we notice we have here is our V1, which is a 120, over T1, which is 293, equals to V2 that we want to find, over our T2, which is 323. And so therefore to make V2 be the subject of a formula, we'll have 120 multiplied by 323, all divided by 293. And so as a result, we get 132.29 dm cube. All right. And of course, if you notice this, that there is an increase in the volume, right? Because once you increase the temperature, you should have an increase in the volume. So that's one way to also check your answer as well. All right, let's go to the next part of the question. So for part B, is a using the axis of the graph sketch a line to present the relationship between volume and pressure for a fixed mass of gas at a constant temperature. And so the graph will look like this as if you're looking at pressure versus volume, and notice this is different from the question above. This is saying now if temperature is constant. And so what we know about pressure and volume, as you increase the pressure, the volume will decrease. So it is a inverse graph, right? So the graph must look like this. For part 2, it's a write the mathematical formula for the combined gas law. And the combined gas law, you must have the volume, the pressure, and the temperature. And so therefore V1 times P1 over T1 is equal to V2 P2 over T2. And again, remember that temperature is always the denominator. And so also as a simpler version is that V times P, which is volume times pressure, over temperature, gives a constant value. For part 3, it's a helium-filled balloon has a volume of 25 centimeters cube at 298 Kelvin and 2 atmosphere. Calculate the new volume in dm cube of the balloon at 4 atmosphere and 283 Kelvin. And so this you have to use the combined gas law because you have all 3 variables. You have volume, you also have pressure, and you also have temperature. All right, and so what you want to find here is the new volume, which is V2. And so based on the combined law as well, you're going to have V1 times P1 over T1 equal to V2 P2 over T2. And so what we're going to do is cross multiply the equation to end up with V1 P1 times T2 equal to V2 P2 times T1. And then you're going to make V2 be the subject of a formula. And so therefore V2 is equal to V1 times P1 times T2 all divided by P2 times T1. And hence you get V2 equals to 25 multiplied by 2 multiplied by 283 divided by 4 times 289. And as a result, we get 12.24 dm cube. Now for part C, the state environmental condition caused by having too much carbon dioxide gas in the atmosphere, and this is called global warming. All right, and that's a common question that most of you remember. All right, so question number 2, it said the balance equation for the reaction of phosphoric acid with magnesium hydroxide is given. And so it is stated here, as you can see. And it said in this reaction, 23 centimeters cube of a 0.25 moles per dm cube of phosphoric acid, all right, which is A3PO4, is titrated with magnesium hydroxide, which is Mg open bracket OH close bracket 2. The titration results are shown in the table. And so here you have a rough titrate. You have the titrate here, which is 22.2, and then the second one is 22.3. And so our first question here, part A, is a calculate the number of moles of phosphoric acid used in the reaction. And so to find this, what you're going to do is go back up into your question here. I'm going to highlight for you right here. You have the volume and you also have a concentration. So once you have those two, which is volume and concentration, you can find the moles, because mole is equal to concentration times the volume. But the first thing we have to do, since the volume is in centimeters cube and the concentration is in moles per dm cube, we have to convert the centimeters cube into dm cube. Hence, we have 23 divided by 1,000, give you 0.023 dm cube. And so now to multiply that, our 0.25, which is our concentration, by our volume, what we get is 0.0575 moles. For part 2, it's to determine the average volume of magnesium hydroxide produced. And so to determine the volume, determine the average volume of this, what you're going to go is the data chart. And I want to just point out here, in terms of your trials, the first one is a rough one, so that is not used in calculation because it will be a little bit above the endpoint of the reaction. So we do not use that. It's just for rough measurement, all right, or to kind of have an estimate as to how close the endpoint of the reaction will be. So we need to use these two within the calculation, and so we're going to average those two out. And so as a result, we get here as an average, all right, we will get over 22.2 plus 22.23 here with divided by 2. So what we get here is 44.5 divided by 2. Hence we get 22.25 centimeters cube. And so if we get that as centimeters cube, we divide by 1,000. And so as a result, we get 0.02225 dm cube. All right, because the axis in dm cube, but the chart had the volume in centimeters cube. So you have to look for those conversions as well. Now for part 3, it's a used equation given in A1, determining the number of moles of magnesium hydroxide. And so if you look at the equation, you realize there's a 2-to-3 ratio. And so it's a 2-to-3 ratio. Let's go back to the equation real quick right here. So it is a 2-to-3 ratio between the acid and magnesium hydroxide. And so what we're going to do here to find this mole, I'm going to divide the 3 by the 2 to get 1 part. And so we're going to multiply that by the mole of that we already calculated. And so therefore what we're going to have right here now is 0.08625 as our moles of magnesium hydroxide. All right, so let's go to part 4. And in part 4, so using the volume in A2 and the moles in A3, determining the concentration of magnesium hydroxide. And so to find the concentration, it is the moles divided by volume. We already have our moles, and we have our volume. So the mole is right here, and then our volume was 0.022225. And so once you divide that, what you get is 3.876 moles per dm cube. All right, so let's go to part B. And part B says state one use of magnesium hydroxide. And magnesium hydroxide is called milk of magnesia, and it is a laxative, and it is used to treat constipation. All right, so you make your bowel movements a little better if you have any problems. All right, but you should not consume magnesium hydroxide without any form of medical advice. It could be dangerous as well. All right, so part C is a give the balance symbol equation for the reaction between magnesium hydroxide and sulfuric acid, which is H2SO4. And so as you know, an acid reacts with an alkaline or a base will give you salt and water. And so based on the equation, this is the equation right here. All right, so we're going to get the balance equation. We need 2 moles of water to do that. All right, so the equation is just as simple as that. Now, for question number 3, it's a diagram shows the electrolysis of copper sulfate using copper electrode. And so what they're going to show here is the electrolytic cell. As it's set up, you have electrode A, electrode B. Electrode A is positive, electrode B is negative. It's a identify A and B as anode and cathode. And so to remember now, the negative will be attracting the positive things, and so they attract the cations, and so it will be called the cathode. A will be attracting the negative ions, which are called the anions, and so it is called the anode. All right, so A will be our anode and B is our cathode. Now for part 2, it says describe the composition of electrodes A and B, and in terms of their charges, is that A, they contain positive charges, all right, or you can say positive charged protons, and B, they are negatively charged, so therefore there's a lot of electrons present in the negative electrode. For part B1, it's a draw to show how the positive and negative electrodes would look after the reaction has occurred. And so just to make a note right here and to show you exactly what's going to happen is that the positive electrode will decompose, all right, or dissolve, and so you know this is kind of breakdown. However, the negative electrodes will become filled or coated with copper, so it's coated with copper, and simply because the negative electrodes will attract the positive copper ions, and they will become deposited or coat that electrode. All right, and matter of fact, to just kind of outline this real quick, is that the reason why this decomposes is because it is losing copper plus ions, all right, as the negative ions will come towards it. It will also give up the positive ions. So when it loses electrons from this electrode, once copper loses electrode, they form copper ions, and so the copper ions that are formed will end up go into the electrolyte. All right, and so hence the size of the electrode, positive electrode, will decrease. All right, so I might have. Let me just quickly see if I could outline that for you. So imagine, for example, let's say oxygen comes here, right? Let's say oxygen comes here, and electrons are passed on to oxygen. So if electrons are passed on to oxygen, I want you to just remember this. This is a basic chemical reaction that you need to remember. So if electrons are passed to oxygen, for example, then what you form is Cu2+, right? Because 2 electrons will go over into the oxygen. And so if you have C2+, then it will not stay on the metal because the metal already is a positive charge. So it will end up go into the solution or the electrolyte. And that's why it is losing copper 2+ charge all the time, or copper ion, you may want to say that. And since you keep on losing that, then eventually it becomes less. All right, so let's go to the next question now. Our part of question. All right, and so the next part of question here is said, write the equation to depict the reaction at the positive electrode and at the negative electrode. And so the reaction of the positive electrode here, again, remember now, so reaction at the positive electrode is this, is that the copper itself that I just showed, this is a copper electrode, which is solid. The copper electrode is solid. It will lose electrons by giving up electrons to the negative ions, and then it will also produce copper 2+ ions. So this is the electrode. This is the electrode actually that I'm showing you, right? Let me just underline this. This is the electrode that is actually at the positive electrode. So it is the electrode itself. It is a solid. It gives up the positive copper ions just because it supply the negative ions with electrons. All right, and so at the negative electrodes now, the positive the positive copper ions will attract to the negative electrodes, and while it is doing that, what will happen here? It will gain electrons and become a neutral element again, or metal. And so this is the deposit. So here is the deposit, and here is the loss. Okay, so just to make a note right there. All right, let's go to part C. And for part C, which is the last part of this question, is electroplating is an important chemical process. Give 2 reasons for its importance, and there are many importance for electroplating. One is to increase strength, the strength of the metal. One is to provide protection, to improve appearances, to make sure the metal look nice. Sometimes it is too dull. They want to make it a little bit shiny, so they deposit a metal that is more shiny. Also to improve conductivity of electricity or heat, increase hardness of the metal as well. Also to reduce friction in some cases, prevent corrosion, and also to reduce rust. So those are some of a few reasons why electroplating is done. All right, so next question is question number 4, the last question in section A. It says sulfuric acid is a commercially important chemical. It is produced during the contact process. In stage 1 of the process, sulfur is burnt in air to make sulfur dioxide. And here now is the equation for the reaction in stage 2 of the process is shown. So in the first stage, you produce sulfur dioxide, but in the next stage, you produce sulfur trioxide. All right, so the reaction occurred at equilibrium, and so define the term equilibrium. And so equilibrium is defined as the rate of the forward reaction is equal to the rate of the backward reaction, or in simpler term, is that there is no net change of concentration of the reactants and the product. So there is no net change. All right. So whatever is going forward is equal to backwards, because remember, it's a reversible reaction. All right, so that's when equilibrium is met. All right, so for part 2, it's a name the catalyst used in this stage, or in this stage 2 of the contact process, and it is vanadium pentoxide, which is V2O5. All right, and that's a common question. I think this was on question paper 2019, I think. I can also remember that. I think it was there. All right, now for part B, it's a use Lechaltier principle to explain the changes, if any, in yield of sulfur trioxide. And so just to make a note here, the first part is that if you have total pressure of the system was increased. So if increased pressure, what will happen is that if you think about the reaction again, if you go back to the reaction, let me just go back to the reaction and show you what exactly is happening. Because see the reaction here, as a total for the reactant, you have 3 molecules. So in terms, you have 2 molecules of sulfur dioxide and 1 molecule of oxygen. So there's a total of 3 molecules on the reactant side. On the product side, you only have 2 molecules of sulfur trioxide, right? So I'm going to use that to kind of explain exactly what I'm going to say right here. All right, so based on the Lechaltier principle now, right? If you increase the pressure, and remember that pressure now based upon particles and volume and all of that type of thing when it comes down to gas. Now, if you increase the pressure, what will happen now? The reaction will favor the fewer molecules, which is the product side. All right. And so, or the product side is called sulfur trioxide, right? And so, hence, what will happen? The equilibrium will shift to the right and produce more sulfur trioxide to kind of balance out the equation. All right. So, think about particles again. More particles mean more pressure generally. All right. All right. So, for part 2, it said if a catalyst was removed. Now, a catalyst is also used to speed up the chemical reaction. And so the catalyst itself does not affect the equilibrium. The only thing it does is really to affect the speed of which the reaction takes place. So, in other words, now what's going to happen here is the catalyst does not affect the equilibrium or how it shifts. However, now removing the catalyst will reduce the time in which equilibrium is reached. So, again, it has no effect on the equilibrium at all. All right, only thing it does is to affect the speed at which equilibrium is reached. All right, so it will not cause any change. All right, so part C now is the final stage of the process of sulfur trioxide reacts with water. It's a right of balance. All right, the balance symbol equation for this reaction include state symbols. And so if you have sulfur trioxide, which is a gas, it reacts with water, which is a liquid. Then what you get is sulfuric acid, which is aqueous solution, right? And so just to kind of highlight a little bit more so you could see it. All right, so that it's right there. Now, so sulfuric acid is a powerful oxidizing agent. Name another property of sulfuric acid. And sulfuric acid definitely is corrosive. I mean, all acids are corrosive. All right. All right, so next part of the question is last part of this question is write a word equation for the formation of ammonium sulfate from sulfuric acid. And so this is the equation right here. You have ammonium hydroxide, you have sulfuric acid, and what you get is ammonium sulfate and water. All right, so this is the end of this part of this question. What we're going to do now is to jump into section B. And section B is where you can choose only one of 3 questions. And again, to make life easier and faster, we already prepared this. So we're going to be running through it quite easily or quickly. All right, so again, you need to answer any 2 questions from this section. And so question number 5 is a student reacts equal masses of sodium hydrogen carbonate, which is NaHCO3 tablets. And it said that the area of 5 grams with equal volumes, which is 30 centimeters cubed, but different concentrations of sulfuric acid. All right, and so you have the same mass, you have the same volume, but the difference is within the concentration. So the results are shown in the table right here. And then you notice you have time, and then you have the different concentrations. So this is just a 1 molar concentration is at 2.5. And now you notice the different volumes of gases that are produced. And so let's go into the part of the question now. So using the data in the table, plot a graph of volume against time for the 2 different concentrations of sulfuric acid, which is H2SO4. Label the plotted lines trial A and trial B respectively. And that's for 6 marks. And so I'm going to quickly point out the things that you need to have for your 6 marks. You need to have a title. I think my thing gone up a little bit too much. All right, I never realized that, but it's up a little bit. There's a title there. And so you should always have a title. All right, so that part is missing. I have that definitely. And you have the labels on the axis. Please label the axis as well. All right, make sure the axes are proper labeled with units as well. See the units and the quantity. Make sure you do that. Make sure you use proper scales as well. But the idea is that a graph will look something like this. All right, that's how your graph will look. You label them as trial B, trial A. And notice that both of them reach the same point at a certain time, but they reach up at different timing because one reaction is going to be faster than one. All right, but again, they're going to produce the same amount of gas. All right, and so using the laboratory apparatus, which is so this is part 2 of the question, I should say, right? So using laboratory apparatus, sketch a diagram demonstrating how a student can conduct the experiment in A13. And this was the same diagram I've used in paper 2019 to explain because it's the same setup. So only difference you use in different reagents, but it's pretty much the same setup. You're going to collect the gas over a period of time. You need a stopwatch, you need a conical flask, and matter of fact, what you need to do whenever you draw a diagram, please annotate it. What I mean, say something about the diagram. Do not just draw a diagram and just leave it like that, especially if they say use the diagram to explain something, right? So talk about exactly what is happening. I just want to show you a diagram and explain how it is happening, how it take place, or how you use the diagram or the apparatus to carry out the experiment. So please not just leave it there without saying nothing at all. All right, it's not a good practice. It's not a good practice, especially if they say explain. Now for part 3, it's a write a balanced chemical equation for the reaction of sodium hydrogen carbonate with its NaHCO3 with sulfuric acid to form sodium sulfate with its Na2SO4. That's a 2 marks, and so this is the equation right here. And so if you notice, the equation is also balanced as well. All right, again, you know once you react a carbonate with an acid, what you're going to get is a salt, carbon dioxide, and water. Again, you need to practice writing state symbols as well. All right, a point to note right here, anything that contains water is generally aqueous, so you can make a note of that. All right, so once a substance contains some form of water or water was formed as a product, they know that the substance generally is aqueous. Typically as well, if you have 2 aqueous solutions or reagents, one of the product is typically an aqueous solution as well. And again, you might find some precipitate in some examples, all right? So you may find a solid as a precipitate, and you also will get partly part of a substance or part of a product being aqueous. All right, so look out for those basic things that you can at least know when to add them in. Now, part 4 of this question is state which trial is faster use the collision theory to explain the difference between the rate of A and B. And so based on the graph that we had, trial B is the fastest, and even the table shows that as well, because they produce more gas in a shorter time. And so here now, by collision theory, is that generally if you have higher concentration, as in trial B, it results in more particles per unit volume. And as a result, as it stay right here, hence a greater chance or more collision may take place. And properly stated is that you have a greater chance of more successful collision between the particles. All right. And also to note that on the other hand, lower concentration, as in trial A, reduces the chance of frequent and successful collision of particles. All right, because remember now, based on the collision theory, that particles must collide frequently and also in the correct orientation. Yes, the particles may collide, but if not colliding in the correct orientation, then no chemical reaction will take place. All right, just to make a note of that. All right. So here now, part 5, it said that 30 centimeters cube of sulfuric acid, all right, with this H2SO4 in trial B was reacted with sodium hydrogen carbonate. Again, it is NaHCO3 tablet. Calculate the number of moles of sulfuric acid. And so we have a volume here of sulfuric acid that was used. And so again, notice that this volume is in centimeters cube. So what we're going to do is to convert that into dm cube. All right, because we have our concentration already in dm cube. And so the mole here going to be molar concentration multiplied by volume, and the molar concentration in the chart was 2.5 moles per dm cube. And so we're going to multiply it by the volume in dm cube. And so as a result, we get 0.075 moles of the sulfuric acid. All right, let's go to the next part of the question now. With this part 6, it says using your answer in A5 and the equation in A3, calculate the mass of sodium sulfate with this Na2SO4 produced. All right, so the first thing we're going to do is to look at the mole ratio, because we already have our moles already, right? So it's the mole ratio between the two substances here, which is sodium sulfate and the acid that we have used right there. So here now is a 1-to-1 ratio. So therefore, the mole as well for sodium sulfate will have to be 0.075 as well, because a 1-to-1 ratio. Now to find the mass, what we're going to do is to here is multiply the mole by the molar mass, and the molar mass here is 46, which is 23 times 2 in sodium sulfate. Sulfur is 32, oxygen is 16. 16 times 4 is 64. So you add up all of that, you get your molar mass, and your molar mass is going to be 142. So you're going to multiply the mole by your 142 to get 10.65 grams. All right, so that is the mass of sodium sulfate. All right, let's go to the next part of the question. It's a trial A was repeated with 5 grams of powdered sodium hydrogen carbonate instead of solid tablet. All other conditions were kept the same. It's using the collision theory again. It's to explain whether the solid or powdered form of sodium hydrogen carbonate will react faster. And based upon this, we know that the powdered form will react faster, because what happened here is that you have more particles are available due to larger surface area, hence faster reactions. And so again, why you have faster reaction? Because again, you have more possible or greater opportunity for successful collision. However, since the mass is approximately half, this is now key. Since the mass is approximately half, all right, you have less gas will be produced, the reaction will be completed in less time. All right, so just to make a note as that. So you have less amount of mass, which means less amount of particles, so your reaction will complete in a way faster time. Now for part C here, it said the presence of calcium hydrogen carbonate in water causes temporary hardness. So it is temporarily hard, and I said what is temporary hardness? And temporary hardness is when that hardness is able to be removed, and so we say hardness is removable by boiling, especially. And I said the boiling process makes the hydrogen carbonate turns into bicarbonate, and bicarbonate now becomes a more precipitate in a sense. Just like, for example, you have so it turns the hydrogen carbonate, which is insoluble, and this insoluble again is moving from bicarbonate or hydrogen carbonate into carbonate. So it turns into like limestone, in other words, right? So like you get a chalky type of thing. So you get a white precipitate generally. So most times when you see white precipitate, is either for sulfate or a carbonate. But in this case, for hardness, it is due to bicarbonates or hydrogen carbonates turn into carbonates. All right, just to make a note of that. All right, so for part 2 right here is a state one way in which this temporary hardness can be removed, and as mentioned in the explanation as well, it is removed by boiling. And again, boiling, as was explained, just to kind of give another brief reminder, is that the boiling returns the bicarbonates into carbonates. All right, so you're turning the almost colorless compounds into a precipitate, in other words, right? So heat will help to form those. All right, so this one now, question number 6, which is we almost there to the end. It's a use a flow chart to answer the questions. And so this is a chart which is a qualitative analysis type of thing here. And so I'm just going to run through it real quick. And so here we have nitric acid here reacts with potassium hydroxide. And so I'm going this side because it's kind of easier for the most part. And so if you have a nitric acid, an acid reacts with a base or alkaline, what you get is must be salt and water. And so you get compound F and liquid. So there's a liquid E, and so we know that liquid E will be the water, and the compound F will be the potassium nitrate that is formed between the potassium hydroxide and nitric acid, right? Again, just to make a note, at the bottom of this chart as well, they have liquid E, so both of them are the same thing. So here is also water as well, right? So this is H2 as well. All right, so these are the same thing. All right, and of course, and then just to make a point right here that water turns anhydrous copper sulfate into blue. All right, so it becomes a blue substance once you add water to it. And anhydrous is without water, which is a solid form. And so here now is a nitric acid now reacts with green solid A, and then what you're gonna get as a result is a yellow-brown liquid, and then a yellow-brown liquid plus other substances, right? So what kind of work this out is kind of run through it in terms of kind of try to figure out the two equations at the same time, because I'm saying here now, what reacts with silver nitrate, right? That will form a white precipitate. So generally it's a sulfate, right? It's a sulfate that normally reacts with silver nitrate to give a white precipitate. And so since I know that, I say, okay, the anion is a sulfate, right? Again, green solid, there are two green solids that we normally think about when we think about qualitative analysis. We think about one is an iron sulfate, or we could have copper carbonate as well. But we know this is not going to be copper carbonate because the copper carbonate will not react with the silver nitrate necessarily to produce a white precipitate. So I'm looking at that and I eliminate that one out and say, okay, I go with iron. And so iron now, again, not only that, why I choose iron as well, because I get the brown liquid here, which is iron 3 nitrate. The brown liquid definitely will have to contain some iron in it. So, right? So there's two kind of ways I can eliminate the other substances. And not only that, does I point out something here again, is that if you notice, if you look at the information here, it said when I had iron sulfate and sulfuric acid, a brown ring is formed. So if a brown ring is formed, then if a brown ring will form, for sure we know that this substance here must be a form of a nitrate, because this is a nitrate test. You're testing for nitrates. Want to see that brown ring? That's nitrates you're testing for. So whatever compound form from these two must be a nitrate. All right, so that's one thing you can look out for as well. There must be a nitrate. They're a nitrate compound. And so we have an acidic brown gas, and acidic brown gas is nitrogen dioxide, right? And again, is only become brown under certain conditions, just to make a note of that. And so it's an acidic oxide. And so an acidic gas that reacts with ammonia to give you a white solid, and that is hydrogen chloride or hydrochloric acid. All right, just to point that out. All right, so, okay, we already complete that. It's identify the stuff. Okay, I go ahead and identify them already. Now look at part 2 here now. It's a state 1 use of compound F. And compound F with this potassium nitrate is to make fertilizers, right? All right, part 3 is to describe what happens if compound F gets into the river. And this also gives you a clue that this is a fertilizer, right? So if you get fertilizer in the river, what you're going to get is an excess growth of algae or overgrowth of algae, which is called eutrophication. All right. Part B now is to write a chemical symbol equation showing the manufacture of nitric acid when nitrogen oxide and oxygen are dissolved in water. I noticed they didn't specifically state nitrogen dioxide. That's one point that also says nitrogen oxide. They state, so the reaction will look something like this, as in a balanced form. A matter of fact, again, try write your state symbols. NO is a gas, O2 is a gas, H2 is a liquid, HNO3 is aqueous solution. Now, let's say give one use of nitric acid here, and so nitric acid is used to produce production of fertilizer, can use to clean jewelry. Matter of fact, any acid can use to clean jewelry if it is real gold or silver. All right, if it's not real gold or silver, it's going to turn black. All right. However, it can also use to make explosive and also in dyes. All right, and many other uses for it. Many uses, but are some of the basic uses. Now for part C here, so the diagram shows a part of the nitrogen cycle. And so we have C, we have A, we have B. Okay, so only have A, B, and C, and anything that is missing. It said nitrogen is an important compound in living organisms, state the form in which it is found in plants and animals. So to find nitrogen as a compound in our bodies, what you're going to find, or even any living organism, to a matter of fact, it is normally in the form of proteins. So proteins will be our answer right there. It's a name the kind of bacteria that carry out the process A and state the compound they form. And here it is nitrogen fixing bacteria. The component, right, the compound that is there, but is actually nitrates. So they form nitrates compound. I should have put that in. Let me type that in real quick. So the compound that is formed right here is normally nitrate. So the compound is nitrate. All right, so they turn nitrogenous gas into nitrates. Just to make a note of that. So they form nitrates compound. All right, just to make a note. And the nitrates compound they will use to make proteins. All right, or actually form amino acids then used to make protein. For part 3, it's a give one way in which the electrical discharge of lightning can have a negative impact on the environment. And so there are many ways that lightning can actually destroy the environment. One is by burning or damaging trees. All right, so it could cause the trees to react because, again, it's charge and all living things have some charge in them. And so it can also deplete ions in soil again because ions, they have charge. Lightning will bring some charge as well. And they may even kill organisms. So if you get a lightning struck, it can kill you or kill any animals that may get struck by a lightning. All right, so part 4 is a name the kind of bacteria that would be responsible for the process B. And the process B is actually coming back from the earth up into the atmosphere. And so that is called denitrifying bacteria that change the nitrogenous compound back into nitrogen gas. All right, and so part 5 is a name the manufacturing process at C. And this is to produce ammonia, and this is called Haber process. All right, so part 6 is to write the balance equation for the process at C, which is the Haber process. Include at least one special condition needed for this reaction. Again, we have covered this in 2019, the same exact equation. However, now the condition that I didn't mention in 2019 is that we have a high temperature, which is about 450 degrees Celsius. We also have a high pressure, and that was a question they asked in 2019, whether the process is high pressure or low pressure. It is high pressure because it uses approximately, let me say, at least 200 atmosphere. It can go up to 1,000 atmosphere as well, just to make a note of that, right? And there must be a catalyst. The catalyst is iron, all right? And that question was also asked in 2019 as well. Now for question number 7, it said a hydrocarbon X contains 75% of carbon and 25% of hydrogen. It reacts with chlorine in the presence of sunlight. Here it asks us now to determine the empirical formula of X. To find the empirical formula, again, I've given stages or steps. And so the first thing you're going to do is to convert your percentage into mass. All right, so you're going to assume that there's 100 grams and convert the percentage into mass. And so as a result, carbon equal to 75 grams, hydrogen equal to 25 grams. Next step you're going to do is to convert these masses into moles. And so therefore, we're going to say 75 divided by 12, which is the mass number for carbon. And you're going to say 25 divided by 1, which is the mass number for hydrogen. And so respectively, we get 6.25 and 25. After you have done that, what you're going to do is to find the smallest whole number ratio by dividing each of the moles by the smallest mole, and the smallest mole here is 6.25. And so therefore for carbon, we're going to get 1, and for hydrogen, we end up with 4. And so the empirical formula is CH4. All right, and so as a name, that could be methane, but that's empirical formula, so that's not necessarily actual name, but yes, at this point, we can call it methane. All right. Now it's a state the relative molecular mass of X. And so the relative molecular mass of this compound here is going to be 12 for carbon plus 1 times 4 for hydrogen, which gives us 16 grams. All right, so get 16 grams there for the relative molecular mass. For part B, is another hydrocarbon Y has the molecular formula C4H10. Draw the structure of C4H10 showing all atoms and all their bonds. And so the first thing we draw here are 4 carbons, and each carbon must have 4 lines around them, or 4 single bonds in total. And so based on, because a bond is right here, put on 3 more, the H is there, and so on and so forth, right? And so if you notice that each carbon will have 4 separate lines. Again, you can have double bonds if they were double bonds, but this is not an alkene or alkyne, is an alkane based on the formula. And so therefore it's all single bonds and with our 10 hydrogens. All right, let's go to the next part of the question. Now for part 2, we said C4H10 as can exist as an isomer. What is an isomer? And this is for 2 marks. And so isomer is simply a compound with the same molecular formula but different structural formula. All right, and that's what it is. And so it's a draw an isomer of Y showing all the atoms and all the bonds. Again, I'm going to compare these two to bring out the definition again. So there's the same number of carbons, same number of H's, but they're just arranged differently physically. So the physical structure is different, but everything else, chemical number, the chemical properties here, they are kind of similar. And also, again, the same number of carbon, same number of H's. So whatever atom in the compound is the same atom in the isomer. The difference is that they are arranged differently. All right, that's the thing about isomer. They just arrange differently physically. All right, that's why we say a physical structure is different, or the structural formula is different, but the molecular formula, they are the same. Now for part C, so write the balance chemical equation for the complete combustion of C4H10. And this is butane, just to kind of point it out. I wasn't mentioning the name before, but that is butane. 4 carbon is bute. All right, and so once you're going to combust anything, it must be in the presence of oxygen. So it got butane react with oxygen here, give you water, carbon dioxide, and energy. To balance the equation, when the first attempt, you're going to realize that at oxygen you get 6.5, so just multiply everything by 2, end up with 2, 13, 10, and 8. All right, and so that would be the balance form of the equation. And so he said that in part 2 now, if 10 grams of C4H10 is burnt, determine the volume of oxygen needed. And so the way to work this out, we're using 10 grams of C4H10, which is butane. First, let's find the molecular formula. We find the molecular formula of butane, which is 12 times 4 for carbon, plus 1 times 10, which is 10 for hydrogen. So we get the 58 grams here. And so we're going to say the 10 grams divided by 58 gives us 0.17 moles. And then the molar ratio, based upon the molar ratio, 2 to 13 molar ratio. So what we're going to do here now is to find the mole of oxygen by dividing the 13 over the 2 to find 1 part. What will be the value of 1 part? And so therefore we multiply that by the mole. What you get here is 1.105 moles. All right, and so as a result now to find the volume of the oxygen, what you're going to do now is to multiply the mole by the value at RTP. I'm using RTP since RTP was given on the cover page. And so therefore the mole multiplied by RTP give a 26,520 centimeters cube. All right, and again you can find this in dm cube, and this will be 26.52 dm cube if you should divide this by 1,000. All right. Now for part this, carbon monoxide is one of the substances formed in car exhaust fumes. Is to give the chemical formula for carbon monoxide, and carbon monoxide is just simple CO. All right, and here's what condition result in the formation of carbon monoxide. And carbon monoxide is formed because when you have a lack of oxygen, or generally when the fuel ratio is higher or way higher than the oxygen ratio. So the fuel to oxygen ratio is definitely too high, and so therefore you have incomplete burning or incomplete combustion of the fuel, and hence you have carbon monoxide forming. Let's say you have that yellow smoke. Not yellow smoke, black smoke or yellow flame. All right, and so at the end of it, I'm going to say good luck on the examination. I really wish you well, and I hope you do awesome. All right, I know I'm kind of late, but better late than never. See you soon. Talk to you later.